On this example, we have the limit as x goes to 3 of x squared plus x minus 12 over x squared minus 9. So right away, you want to check that domain. If we plug in 3, we get 3 squared minus 9, which 9 minus 9 is 0. So the value of 3 is going to 0 out our denominator, which we can't have. So that means we want to think about factoring. On the top, we have a trinomial. So what we're looking for here on the top is two numbers that multiply to negative 12 and add up to a positive 1. And you might be able to do this more mental than anything. You might not have to even draw out a multiplication table. But just in case you want to, your factoring's a little rusty, you can just think of it as two numbers that multiply to the n and add up to the middle. Just factoring a trinomial. So just go through your combinations of numbers, multiplying to negative 12, adding up to 1. So adding up to 1, we know it's going to be some sort of version of 4 and 3. So it could either be negative 4 times 3 or 4 times negative 3, because we want to multiply to a negative while adding up to a positive. So negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So that doesn't work. 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. So that works. So that means the top is going to factor to, so I have the limit of x going to 3. And we decided that our factors were 4 and negative 3. So it's going to be x plus 4. X minus 3, this is 4 and negative 3, over difference of two squares, so that's going to be x minus 3, x plus 3. X squared is x times x, 9 is 3 times 3. And then what ends up happening is our x minus 3's will drop out, leaving us with the limit as x approaches 3 of x plus 4 over x plus 3. And then we evaluate the limit as x approaches 3. Here is a massive mistake that I see a lot of students make over the years. Right here. I see people do this so often where they do this. Boom. They cross out the x's because they think, oh, I have an x and an x, so those are going to drop out, so I get 4 over 3rds. That's not how it works. If you had this, let me write out this. If you had x times x plus 4 times x plus 3 like this, then yes, the x's will drop out like that because they are multiples, they are factors of this. So it's x times x plus 4, x times x plus 3, so that would cancel out, leaving us with that. But in this case, it's x plus 4, x plus 3. What a lot of people that I've noticed that once I don't write those parentheses in, they think, oh, it's fair game, I'm going to cross out those x's. If you had the fraction 2 plus 3 over 2 plus 5, let's say, just kind of making up something off the top of my head, you would never do this. You would never just say, oh, the 2's are going to cancel out, leaving us with 3/5. Like, that is not a true statement. That is not how fractions work. Same thing with expressions like this. So, just a little side note there. Now we are going to evaluate 3 going into here. So it's going to be 3 plus 4 over 3 plus 3. 3 plus 4 is 7. 3 plus 3 is 6. So that would be our answer, 7 over 6. So a couple keys to this problem. First of all, notice 3 gets a 0 in the denominator. It zeroes out. So that means we have to reevaluate some things and rethink about what has to happen here. So we got a factor, two numbers that multiply to negative 12, add up to the middle. Factored, difference of two squares, factored, canceled out some terms, nice clean simplifying there. And then we just plug in the value there and we get our answer of 7 over 6.